Assalamu alaikum. This is Matlab course, lecture number 1. In this lecture, we'll talk about the user interface and then talk about matrices and matrices operations. So when you open the Matlab, you can see the user interface like this. By the way, this is Matlab 2019. To the left here we have the home, then plot. You see plots, and here we have applications. We can use the applications. Go back to home. You can open new file, script, live script function, live function class, etc. Or you can open available files from your directory. Also we have here many tools. I will teach you later how to use them as Simulink as example, how to run the Matlab and so on. The first thing, guys, in the user interface here to the left, this area, it is the current folder where you have all files, Matlab files. By the way, it's very important to keep all your files in this current folder. As example, Excel sheets, data, M files, Mat files, everything. Keep them in the current folder. At the middle here we have the command line where you can write the commands script, but this is line by line. That means you can't run a complete program here. You can copy it and run it once, it's okay, but written here, or you can write here one line followed by another line and so on. So the execution will be line by line. To the right here, we have the workspace. In the workspace, you will see the variables, data, and also you can see the results or the output from running the program. Now, as example, let me write a simple code like x equal 5. Run the program, enter. As you see, when x equal to 5, x equal to 5, the result from this code. Now go to workspace. We have a variable. This variable name is x, the value is 5, and the x here, it's 1 by 1 double. That means the data saved by default as a double. In a matrix, because I don't have other value, just one value here, it will be 1 by 1. That means this is a scalar or a matrix with 1 row, 1 column. Here in Matlab, not like the C, you can write directly x equal 5, y equal 5.1, anything, without saying that it's integer or float, because the data here will be saved as a double by default. Can we change the double to integer, or integer 32-bit or 64-bit? Yes. Now say that y equal to 1.5 semicolon. The semicolon here, guys, it's very important. When you write the semicolon, if you remember in the previous example, we wrote x equal 5 without semicolon. So we saw the result in the command line. But when you write the semicolon, then enter, you will never see the result in the command line, but the code executed. And the result, as you see in the workspace, y equal 1.5 as a double. It's 1 by 1 matrix or a scalar value. How we can delete the command line? By typing clc, clear command line, like this, enter. How can I delete the variables from the memory or from the workspace? By the way, the workspace here is the memory of the file. Just write clear. Now if you write clear, it will delete everything in the workspace. Enter. As you see, nothing in the workspace. Let me make undo by control. Use control and Z. Control and Z again. Nothing done. Click here. Control and Z again. Nothing done. It's okay. Let me repeat again. CLC to clear the workspace. Sorry, the command line. Write x equal 5 as example. Y equal 1.5 semicolon, like this. Okay, now as you see, we have x and y variables in the workspace, and I want to just delete the x value, so we can write clear space x, enter. As you see, the x variable cleared. and so on. Now let me go back and CLC, use the CLC to clear the window and clear the workspace, all of the workspace. Now today or for this lecture I will use the command window at the beginning, then I will use a file, script file. So now what is the matrix? A matrix, it is a variable that contains one value or more. It could be one value, it is a scalar like x equal to 5. This is one value, scalar value. It could be more than one value, but as a vector, column vector or row vector. Like we can say that we have t equal, as example, like this, say 1 2 in the first row, and sorry, 1 2 3 3. This is when you use a comma. When you use a comma, that means we are separating the rows. Sorry, we are separating the columns. That means this is in the first column, this is in the second column, this is in the third column, but all of these as a one row. So this vector, it is a row vector. As you see in this vector, the first column it's 1, second column it's 2, third column is 3. Now we can we repeat the same command again but writing semicolon? Yes. Use the arrow head, the upper arrow head on the keyboard, and you can select what you want, then just type semicolon again. Now again, I told you the matrix, it could be a scalar value like x equal 5, one value, or it could be a vector like this one, and the vector, it could be row vector or column vector. Now can I change the vector t from row vector to column vector? Yes, we can use the transpose. We can write just if you want the same variable to change it from row to column, just write t transpose like this, enter. Now see the answer 1 2 3, but still t, same value. It is a row vector, not column vector. But the answer from this command, as you see, it is 1 2 3. And as you see, a and s, it's a new vector. See, in the workspace, it's a new variable. The values are 1 semicolon 2 semicolon 3. Semicolon used to separate the rows, while the comma used to separate the columns. If you want to change the same vector, you can say that t equal t transpose. Now if you see or look to the workspace, as you see, t equal 1 semicolon 2 semicolon 3. That means we have 1 in the first row, 2 in the second row, 3 in the third row. It was before in one row, 1 2 3, 3 values in one row vector. Now it become a vector, a column vector. Now can I change it back to the row vector? Yes, say t equal, let me use another variable like g equal t transpose. Now the g variable equal to t variable transpose. That means if you have equation like this, the equation, the right part should be applied first, then the result will be assigned to g. If we press enter, as you see, the answer, sorry, it's a mistake, press enter, g, as you see, it is 1 2 3 as a row vector. Why? Because t, it is a column vector, transpose of t will be a row vector. Now how we can by the way, x here again, it's a scalar value or scalar matrix. T here, it's a row vector or one-dimensional array. G here, it's also a row vector or one-dimensional array. How can I write a two-dimensional array two-dimensional array, say that we have a matrix M equal like this. We can write, we need it like this, guys. In the first row we have 1 followed by 2 followed by 3, then semicolon to go to next row. In next row at the beginning we have 4 or say 5 followed by 6 followed by 7, then like this, enter. As you see, in the first row we have 1 followed by 2 then 3. The comma here separate the columns, then semicolon to go to next row, then 5 6 7. Can I remove the columns, the commas? Yes, I will repeat. Okay, now I will remove this comma but keep a space, remove this comma but keep a space, remove this comma, keep a space, remove this comma, keep a space, enter. As you see, same result. Now M, it's a matrix, two-dimensional array or matrix. We have 2 rows but 3 columns. Again, semicolon used to separate rows. That means before the semicolon we have a row, after the semicolon we have a different row. So this matrix size, it is 2 by 3, 2 rows by 3 columns, so 2 by 3. By the way, we have functions, built-in functions in Matlab that can be used to find the length of a vector or size of an array. As example, we can use length of, it's a function, use these type of brackets, length of say t, 3. We have 3 elements. We can write size of or size of the matrix M. As you see, the size 2 by 3. That means we have 2 rows, 3 columns. But remember, when you write length of t, we have by default the variable answer. The current value of the answer is 3. When you write size of M, by default A and S variable will be defined. The values or result will be a vector. So answer here, it's a scalar value, while the answer here, it's a vector, 2, 3. The 2 represent number of rows in the matrix M, and 3 represent number of columns of the matrix M. Let me now clear the command window only. Still I have the answer, I have G, I have M, I have T and X. Now, how we can access a certain value in a vector or place, certain place in a vector, or how we can access the any value in a matrix, two-dimensional array or matrix. As example, I want to take the second element of T, which is second element of T, it is 2. I want to change it to 5. So we have to index. So the indexing in vectors and matrices like this. So you have to put the variable name here, T, followed by a bracket like this. So T of what? The index of the second element is 2. It is not like the C. In C, if you remember, the index of the first element is 0. The index of the second element is 1, and so on. But in Matlab, it's easier. The index of the first element is 1, the index of the second element is 2, and so on. So we need T of 2, that means the new value of the second element equal the old value of the second element, or you can change the value directly by 8, like this, semicolon, enter. Now go, if you remember the second value, it was 2 before. Now go to the T, as you see, it is 1, then 8, then 3. If you want to display the value, just write T, enter. As you see, 1, it was 2 before, and then 3. The second element here, T of 2 equal to 8. That means the new value, which is 8, will be saved instead of 2. The 2 will be deleted. How we can access an element in a matrix, two-dimensional matrix? We can write the following. As example, I want to change the element in M. So like this, here we have to write comma. Before the comma we have to write the line number. Say that go to row number 1, column number 2. That means go to let me delete this one and show you the values of m. Again, we can write m of 1 comma 2. Now m of 1 comma 2, say that equal to -5. Now m of 1 comma 2, that means go to m in the first row, second column. This is first row, this is second column, which is 2. Change the value from 2 to -5. See, now as you see, the second value in the first row changed from 2 to -5. Can I write an equation? Yes. Say that m of 1 1 as example, m of 1 1 equal to m of 1 1 1 1 multiply by -3. By the way, the multiplication operation, it's star in Matlab, and here you can write -3 like this, then enter. As you see, the first element, or go to the row number 1, column number 1, which is the first element, which is 1, and multiply it by -3. So I'm sorry, again, we have equal here equation. The right side should be calculated at the beginning, then the result will be assigned to the left side. So m11, it is 1, multiplied by -3, it will become -3. The -3 as a result will be assigned to m11. So the -3 will change the 1, or delete the 1. We have many things we can do in Matlab regarding the matrices. We have many operations that can be done on matrices. Now let us talk about the colon operator. See, I will make CLC, okay, to clear the command window. I want to generate a vector which is x using the colon operator. The first value of x is 1, and the final value is 10, incremented by 1. That means the values of x will be 1, followed by 2, followed by 3, 4, 5, 6, 7, 8, 9, 10. Why? Because the increment by default, if you wrote it like this, the increment by default will be 1. So as you see, this is a row vector, start from 1 to 10, incremented by 1, or increased by 1. Can I make it decrementing? Yes. Say that y equal, say that from 10 to 5, like this, as you see. Y equal 1, empty double row vector, because this is not normal. So again, repeat, but here we have to indicate how much should be incremented. If you want to decrement it by 1, say -1, to let Matlab understand what it should be done. As you see, when you write y equal 10 to the 5, not acceptable, then you have to indicate -1 as an increment. Can I increment it by 2? Yes. Say that I have z variable like this, sorry, z variable equal to, say that from 5 incremented by 2 to 10, double dot, okay, to 10, like this. Now it means that the first value will be 5, the final value should be 10 or less, incremented by 2. So 5 plus 2 will be 7, so 5, 7, 9. I see 5, 7, 9. Again, it should be maximum 10, but the first element is 5, plus 2 will be 7, plus 2 will be 9. It should not go beyond or after the 10. This is called colon operator. Now we have also a function, a built-in function called linspace. Linspace. It is a function that can be used to generate a vector. Say that I have a vector v equal linspace. I want to start this vector from 1 to 10, but I want from 1 to 10 to be divided linearly and equally to 5 elements, only 5 elements. So I want 5 elements from 1 to 10. They are spaced linearly and equally. So enter. As you see the vector v equal at the beginning, the first value will be 1. It should be 10. The final value should be exactly 10, as you see. And total number of elements, they are 5. So 1, 2, 3, 4, 5. They are equally spaced, linearly spaced. How we can calculate the increment? It is 5 divided by it's 10 minus 1, which is 9. 9 divided by 5, it gives you the increment value. Now we will talk about some function used to generate special matrices. Let me do CLC, okay, to clear the command window, and to clear the workspace, all of the variables in the workspace deleted, and CLC again. Okay, now say that I want to generate a matrix 5 by 5. Okay, and all of the elements are zeros. So we have a function called zeros. Okay, and what is the size of the matrix? It's 5, 5. That means 5 by 5, as you see. If you want it ones, we have a function called ones. Same thing. I want say that 2 by 3 like this. The answer 2 rows by 3 columns, all of them ones. If you want threes as example, you can write 3 multiply by ones. Say that 5 by 5, it will generate a matrix. All of elements in this matrix will be ones multiplied by 3 threes. So the matrix size 5 by 5, that means 5 rows, 5 columns, as you see. What if I want a row vector of ones or zeros? We can do it. Zeros as example, zeros. Okay, say that I want just 1 row, 5 columns like this. Okay, same thing for the other functions. What if I want say a square matrix of ones or zeros? If it's a square matrix, we can write zeros of 5 as example. 5, it means 5 by 5 matrix. Same thing for ones or another function. Now we have functions also like sum can be used with vector, can be used with a matrix. So let me clear the workspace again and the command window. So I have x as example, or v, a vector, v equal from 1 to 5 semicolon. I don't want to see the result. It will be go direct to the workspace. I have a matrix, say m equal say 3 multiplied by ones of say that 2 by 3. 2 by 3. I don't want to see the result. Okay. Oh, sorry. Again, repeat the same command, but write here 3. I forgot to write 3. Enter. If you want to double check, m equal, as you see, 3 because it is 2 by 2. Multiplied by 3 will be 3, and this is the vector v, as you see, 1, 2, 3, 4, 5. Now I want to make the summation or find the sum of elements in vector v. Just write sum. Sum, it's a built-in function, can be used with vectors or matrices. When you write v, sum of v, the result will be 1 plus 2 plus 3 plus 4 plus 5, which is 15. What about sum of m? Sum of m, it will give you what? Sum of m, it will give you the addition or the sum of each column. So the result from sum of m, it will be a vector. So the first value in this vector will be sum of 3 plus 3. the first column, and the second column will be the second column addition of 3 and 3. If you want the total sum, you can write sum of the sum of m. As you see here, we have sum. The inner sum will be finished at the beginning firstly, so we will get a vector with 6 and 6. Then sum of this vector, it will add 6 to 6, and the result will be 12, as you see here. This is the sum. Can I find the sum? Can I find the sum of each row individually? Yes, we can write sum of m, the name of the matrix, say 1. I will show you what this means. It will give you the the column summation. Repeat the same command, but write 2 here. It means the second option, which is sum of each row individually. So when you write sum m comma 2, that means the second option where you can find the sum of each row. So the first row, if you remember, the first row summation will be 6, the second row summation will be 6. As you see, we will get a vector, column vector, while here we got a row vector represent summation of each column, and so on, guys. What about the matrix multiplication? Let me clear the workspace and the command window. Let me define this matrix. Say that matrix number 1 m1 equal, say that ones, to make it simple, ones of 5. As you see, it's 5 by 5 size. Okay, and I have matrix number 2, say that threes, say that equal to, say that 3 multiply by, as you see here, multiply by, we have 5 by 3, as you see. So I'm sorry again, invalid expression when calling a function or indexing of a variable. Again, let me repeat, we forgot to write ones, 3 multiplied by ones to get threes. So m1, as you see, it's ones, 5 by 5, and the size of m2, 3, we have 5 by 3. Let me show you what that means. Again, if you look to the size of the first matrix m1, it is 5 by 5, and the size of the second matrix, it is 5 by 3. If you remember in math, we can do the algebraic multiplication of matrices if the inner dimension same, as you see here, it's 5. So we can do the matrix algebraic multiplication directly, no problem. Let me show you the result. So we can write m1 star m2 and see what is the result. This what we get. Actually, as you see, we will get something, or the size will be, the matrix size, the new matrix size will be 5 multiplied by 3. So what if I multiply the m2 by 1? So let me do it again here. If we do it again, the matrix of m2 size will be, again, as I told you, it will be 5 multiplied by 3, while for the second one, which is m1, it will be 5 multiplied by 5. Now the inner matrix dimension, it is 3, and here it's 5, and that means we can do the matrix algebraic multiplication. Let us check again. So this is m2 multiplied by m1 and see what is the result. Error using multiplication, incorrect dimensions for matrix multiplication. Check that the number of columns in the first matrix matches the number of rows in the second matrix. To perform element-wise multiplication, use the dot star. This is very important. Element-wise, that means element by element. But to perform element-wise multiplication, the size of each matrix should be the same. So you can find an element in M1 corresponding to element in M2 and so on. So if I want to do that, let me show you. M1 dot star, that means element by element. M2, wrong also. Why? Matrix dimensions must agree. They should be the same. Let me clear the workspace and define M3 equal, say, 5s. So 5 multiplied by 1s, okay? And the size like M2, it will be 5 by 3. So 5 by 3 like this. As you see, again, let me remind you what's the M2. This is M2. Now I want to do element-wise multiplication, or element by element. So we can write M2 multiplied by M3 like this. Now see the result. Wrong. M2 by M3. Wrong, because this is algebraic multiplication, and the inner dimension for the matrices should be agree, should be the same. But can I do element by element? Yes. M2 dot star, dot star, the dot before the operator. So dot star M3. See the result, 15. So we have a matrix, the size of the new matrix same. It will be 5 by 3. Can I use the dot with division? Yes. Can I use dot with power? Yes. Can I use, when you use dot before any operator, that means you are doing not algebraic operation, you are doing element-wise operation, or element by element. See, I'll see again. See what I will do. I want to generate a matrix, say G equal to the power of M1 to 2. When you write when you write M1 to the power 2, this is the operator of the power in MATLAB, and this is 2. This will not be no, it's okay. Why? Because come on, let me show you why it's okay. Because when you write to the power 2, that means multiplication. That means G equal M1 multiplied by M1. So when you write G equal to, when you write G again, sorry, when you write G equal to M1 multiply by M1, this is the power 2. Now M1, it is 5 by 5, 5 by 5, and M1 same, 5 by 5. The inner matrix or inner dimension of the matrices are agree. We can do the multiplication, algebraic multiplication. And at the same time, because the same size M1 and M1, we can do element by element. I will show you the element by element. Just put dot here like this. Okay, so M1 dot to the power 2, that means element by element. So if you remember the G1 value, the M1 value, I will show you the M1 value. This is the M1 value. If you remember the M1 value, it is 1 followed by 1, 1, 1, 1, all of them ones. So 1 to the power 2, it will be 1. 1 to the power 2, it will be 1. So good. What about M1 to the power 2, but the algebraic multiplication? If you remember how we can do, I will let you remember how we can do the multiplication. Let me take it as a 2 by 2 matrix to simplify the multiplication. If you remember, if we have like this, I will show you. If you have a matrix 1 and 1, 1 and 1, multiply algebraically by another matrix, which is again, say 1, 1, 1, 1. How we can multiply them? If you remember, we will take the first row, multiply it by second row, by first column of the next matrix. So 1 will be multiplied by 1, so 1 will be multiplied by 1, and the other one will be multiplied by the other one, and take the result, the summation result. So 1 by 1 it is 1, plus 1 by 1 it is 1, so the result will be 1 here. Okay, next we will take the next row with the next column. Same idea, it's 1 by 1 will be 1, 1 by 1 it will be 1, and the result will be 2. I'm sorry, the result will be 2, not 1 here. I forgot that, sorry. So the result will be 2 followed by 2. So we got a matrix 1 by 2 like this. So this is the result. Okay, let us do it again. Say that we have G equal ones. Say that ones, the size of G is 2 by 2, or write 2 because it's a square matrix. Now see, it is right now G multiplied by G, and see the result. G multiplied by G, it is 2, 2, 2, 2. That means we have 2 rows by 2 columns. That's true. Maybe I forgot something here. Again, the first, okay, I'm sorry again. Let me do it algebraically second time. In this example again, guys, the first row multiplied by the first column, the result will be 2, as I told you before. The first row again multiplied by the second column, the result will be 2 again. Then go to the next row multiplied by the first column, the result will be 2. Then the second row multiplied by the second column, the result will be also 2, because 1 multiplied by 1 it is 1, plus 1 multiplied by 1 is 1. The result will be 2, and we got 2 by 2 matrix, and this is correct. Let me also talk about how to use the say that the index of the array to generate a new array. Say that as example we have a array called a. It is equal to the following. Okay, the first element is say 1 followed by 2, 3, 4. Say 4. I'm sorry, 4. Again 1 followed by 2, comma 3, comma 4, comma 5, comma 5. Then I will go to next row, semicolon. Say that we have 6, comma 7, comma 8, comma 9, like this. Okay, again 1, 2, 3. I'm sorry, this is what here. 1, 2, 3, 4, 4. 1 again. I'm sorry. It's 1, 2 followed by 2, comma 3, comma 4. Then 5. So we have 1, 2, 3, 4, 5 elements. And here 1, 2, 3, 4, 5. Let me add the 10 here. So we have 2 by 5. I want to generate a new matrix called AA equal to A. I want to take from A. I want to take from A the first row, okay, comma, all columns. Double dot this one, it means after the comma, it means all. Now it is the first row, all columns. As you see here in the result, go to the A, take the first row, all columns in the first row. So all of the columns in the first row, as you see. Let me write AA equal, take from A, all of, say that all rows in column number 2. All rows on column number 2. So go to A, all rows in column number 2. This is number 2, the first row, second row. Can I say that also AA as example equal to, remember that AA, when you redefine it, the new definition will be the old definition. So AA equal, or take elements from A, say that go to the first row, take element from 2 to 5, 2 to 5. See the result. Go to A, first row, this is the first row, take the element from 2 to 5, element number 2 to 5, the second element, or second column, third column, fifth column. By the way, this is the value, the same of the index. It's just an example. Say that AA equal, go to A, take the first row to the third row, from the second column. First go to the A, take from the first row to the third row of the second column. Now where is the second column? By the way, we have just 2 rows. We can write from 1 to 2 like this, from 1 to 2. Now in this go to A, take the first and second row from the first to the second row of the second column. Where is the second column? This second column. Okay, this is the second column. Take from 1 to 2, from the first row to the second row. So the result will be a vector with 2 and 7. This is how we can use the matrix indices to define a new matrix or change a value of any element inside the matrix. Now let us talk about the matrices, the identity matrix and the inverse of any matrix. If you remember the identity matrix I for any matrix, no, sorry, not the I as complex number, sorry, CLC again. If you remember the identity matrix, it is a matrix where the diagonal elements or elements in the diagonal will be 1s and the other elements 0s. And if you remember, if you multiply the matrix by its inverse, you will get the identity matrix. But remember also the matrix should be squared matrix, and it's not all matrices, squared matrices, have an inverse. So as example, let me define a matrix, or take any matrix from here. Say that M1. How can I find the inverse of M1? Write inverse INV. It's a built-in function, can be used directly. Inverse of M1 and see the result. Warning: the matrix is singular to working precision. Singular matrix. That means we don't have an inverse, or the values are infinity. Look to M2. M2 it's 5 by 3. We don't have inverse for this matrix. Let me define a matrix. Say that MM equal say 1, 2, semicolon 3, 4. It's 2 by 2, 3, then 4. Now inverse of the M1, MM, this is the inverse, -2, 1, 1.5, minus 0.5. Let me check. Right, MM multiplied by inverse of MM, what we will get? The identity matrix. See, the diagonal elements, they are 1s, and the other, they are 0s. We have also another function called product. We have a vector here. If we have a vector here, we don't have a vector here. Let me say that we have a vector v equal, as example, from 1 to 8, incremented by 0.5 as example. So the increment is 0.5. This is the v vector. I want to find the product. Or let me simplify it. Say that v equal from 1 to 5. Like this. These are the elements of this vector. Write product of v. What will be the result? The product of the elements inside v. That means product of v equal to 1, the first element multiplied by second element multiplied by third by fourth by fifth. So 1 by 2 it's 2, 2 by 3 will be 6, 6 by 4 24, 24 by 5 will be 120. What if I use the product with a matrix? It will give you the product of each vector, sorry, each column. So write product of, as example, let me check what is the value of m1 as example. These are the m1 values, or use mm better, mm. So I will find the product of mm, product of mm. See the result. It will give you 1 by 3, it's 3 in the first row. In the second row, the column multiplication, 2 by 4 will be 8. Now let me talk about some special functions like rand function. As you see here, rand function, it's a user, it's a built-in function. When you write rand of n, you will create n by n matrix containing pseudo-random values drawn from the standard uniform distribution on the open interval of 0 to 1. So when you use rand of n, you will get a matrix n by n, arbitrary numbers, or say that pseudo-random values between 0 and 1. Say that rand of 5, it will generate 5 by 5 matrix, and the numbers randomly selected from the normal distribution, or uniform, sorry, distribution in the interval between 0 to 1, 0 and 1 included. Repeat the same command again, you will get different values. Repeat the command again, you will get different values. What about if I want these values integers, not double like this? We can use rand I. So I will use rand I like this, and then you can write as example, we need the maximum value, say that less than 10, the maximum value will be 10 or less, and the size, it will be 5, as you see. These are the results. This is the result, rand I 10,5. That means the maximum value in the matrix will be 10. So select any number between 0 or 1 to 10, from 1 to 10, sorry. And we need the size of the matrix 5 by 5. As you see, all of the values are less than 10 and more than 1, and they are integers, not floats or double. 5 by 5, and all of them between 1 to 10. What about if I want to indicate the minimum and the maximum? I will use the same command again. Write the minimum value is 5, 10, 5. That means 5 by 5, all elements between 5 and 10. Sorry, this is not correct. 5, 10, 5, 10, 5. I did a mistake. The region should be between square brackets like this. If you want to write max and min, you should keep them between these two square brackets. Now you will generate 5 by 5 matrix, and all of elements between 5 and 10. The minimum one is 5, maximum one is 10. See, all of them between 5 and 10. It's 5 by 5 matrix. We have also a function called the mean. If you want to find the average, say that I want to find the mean of the matrix. Let me start by vector v. Mean of the v. It will find the average of v. Just to remind you, what's v? This is v 1, 2, 3, 4, 5. the summation will be 15, number of elements will be 5, 15 divided by 5 will be 3, so the average will be 3. What if I will use the mean of not V, I will use a matrix, say that M3, so it will give me not one value, it will give me a vector. That means it will give me the mean or the average of each column. If you want the average or the mean of the matrix, you can write mean of the mean. So mean of the mean of the matrix M3, just to remind you, the mean of 5 and 5 and 5, it will be 5. So you will get 5 like this. So you can write mean of the mean to find the average value inside the matrix. You can find sum of sum, write sum of the matrix to find the summation of the matrix. What about the maximum value and minimum value? We have a function called min to find the minimum value in the matrix or in the vector. Say as example, vector v, the minimum value is 1. What if I want, okay, let me generate a vector number 2, okay, just to show you. The first element is 6, second element is -7, followed by 9, followed by 8, followed by 3. This is the vector. I want to find the minimum value. Say write min of v2, min of v2. It will return the minimum value, which is -7. What about if I want to know exactly where is this one? Is it the first element, second element, third element? We can write the following. We can write, say that A, comma B, or better to write like the following. Because I'm finding the minimum. Say that mn, it's a variable name mn, and index id or in, index or ix, okay, equal to the min function of the vector number 2. This in this way we will get two variables. The first one, which is mn value, will be the minimum value in the vector, which is -7. And the second one here, it's ix, it will show the index of this value, which is the second one, so ix equal to 2. Same thing in the matrix, if we have a matrix like M3 and want to find the minimum, so write min of M3. It will find the minimum in each column. If you want to find the minimum in all of the matrix, write min of the matrix M3. Okay. I'm sorry, M3 again. I forgot to press the 3. See, minimum of the minimum of M3 will be 5. Same thing for the max. Exactly. Now, how can I find the minimum value in the matrix? Okay, say that select the matrix MM. Okay, again, minimum of MM, minimum of MM, minimum of the minimum of MM. This is MM, and then I will delete this and add a bracket like this. Minimum of MM is 1. Go to the MM. I will show you the matrix MM. 1, 2, 3, 4. Okay. Now, if I want to find the minimum and its index, as example, say that MMM equal a new matrix. The first element is 2, second is 1 minus 5, third -9, and fourth is 0. Next column we have 1, we have 8, we have 9, we have -6, like this. This is the MMM matrix, and I want to find the minimum of the minimum of the matrix. So minimum of MMM, like this. It will find the column. Say that as example, say A, comma B equal minimum of the minimum of the MMM. I will get two values. I will get the first one, it's 9. 9 showed the minimum value, and B, it's index 3. That means in the third column. So in the third column, but we can't know which exactly. Is it in the first row or the second row? Now we'll talk about the round function. Let me write round the value of 6.3. It will be 6. Write round of say 6.7. It will be 7. 6.7. It will be 7. We have also one of the math functions, built-in functions called absolute. You can write abs of minus 3, it will give you 3. The absolute value of minus 3 will be 3. So guys, really thank you for watching this video. In this video we finished the first part of lecture number 1. It's just introduction about the user interface of the MATLAB. We talked about the matrices, vectors, scalar values, how we can use the indexing or indexing the matrix or a vector, how you can change any value inside the matrix and a vector using the element index. And we learned together how we can generate vectors, how we can generate matrices, how we can do multiplication of matrices element by element or algebraic. We learned together also how we can use a built-in functions like min, max, mean, also linspace, length, size, and many functions can be used with matrices and vectors. I hope that this introduction is clear for you all, and you can proceed to do the classworks. Next part for this lecture, we will solve these classworks of the lecture. Thank you so much.